Welcome to another episode of Fort Bend Mathematics Tutoring. Take a moment to soothe your nerves. Remember, these is just numbers. They can't hurt nobody.
Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about the zero factor property part 3. That's right, we're dealing with complex numbers today. That's right, imaginary numbers, our good friend. We'll be taking a look at some of these problems and giving you step-by-step instruction on how to solve them. But first, I would like to ask that you go ahead and subscribe to our YouTube channel, Fort Bend Tutoring FBT, Fort Bend Tutoring, with me, Mr. Witt, and go ahead and click on that bell icon so that you can get notified when we upload new and fresh content for you to digest. I know, right? It sounds fun. Let's go ahead and look at the examples that we'll be showing you today. So here we have 10 problems that we'll be solving today, where we'll be using the zero factor property as the method to solve these equations. That's right, and notice that they are riddled with fun stuff like imaginary numbers and radicals, things that you know well and love deeply. So let's go ahead and take care of all 10 of these problems together. Now, I will remind you guys that you can see a lot of the information that I'm going to be giving you today in the video Factoring with Complex Numbers. That's right, Factoring with Imaginary Numbers. Go ahead and check out that video. I'll be putting a link right up here, right in this area. Over here, right here. So yeah, so check that out. So these are the 10 problems that we're going to do. Let's go ahead and get to it. In number 1, we have x squared minus 5ix minus 6 equals 0. Well, the first thing you may want to do is go ahead and show that this could be rewritten as x squared minus 5ix plus 6 times negative 1. Well, the reason why you would want to do that is because we already have an imaginary number showing within the equation. Well, because of that, we can put this into a quadratic form by rewriting this negative 1 as I squared. So I'll be showing that by rewriting this as x squared minus 5ix plus 6i squared equals 0, and now we have our preferred quadratic form. We'll be going ahead and factoring this by looking for 2 factors of 6 that will add to give us 5. Well, those two numbers will be 3 and 2. So if you need a refresher over how to factor quadratic trinomials, be sure to check out our Factoring Quadratic Equations Part 1 video. That'll help you out with trinomials such as this. So I'll be opening up 2 sets of parentheses here. So I got 1 set of parentheses. Now that makes 2 sets of parentheses. And the first term I'll need in each is our variable x. And then, of course, I'll need an I in order to generate that I squared. And, of course, I said that the 2 factors of 6 that will add to give us 5 is going to be 3 and 2. And you better believe they'll both need to be negative, see, because the sign of the middle term's coefficient will always be the sign of the largest factor that we're going to be using to generate that product of 6, see. And because we need them to add to negative 5, the 2 needs to be negative as well. So we have completely factored the quadratic trinomial that we have. And because we'll be using the zero factor property, we can go ahead and set each factor equal to 0 and solve for it. So we'll end up with x minus 3i equals 0. We got another one that's x minus 2i equal to 0. And from here, thank you, we'll go ahead and solve for each of the equations by adding 3i to both sides in the first equation. So I'll end up with x equals to 3i. And in the second equation, yeah, I'm adding 2i to both sides. Thank you. I know you already knew this already, but, you know, I'm just pointing it out that we end up with x equals 3i and x equals 2i for our solutions to problem number 1. I mean, I had fun with that. I hope you did too. So if you'll be writing your answers as a solution set, you can write it as x equals, and pray for the brace. Thank you. It's going to be 2i and 3i as our solution. See, the right brace is a lot better, but this over here is, we'll just call it artwork. Okay? That's what we'll do. And now we'll be red boxing the answer. That's right. So the answer is right here in the solution set. It's 2i and 3i. There you go. That's problem number 1. Let's move on to our next problem in the tutorial. Here we have 4x squared plus 9 equals 0. And I believe this problem looks familiar because we did this exact problem in the previous video. But this is the zero factor property that we'll be applying to it. So we'll be factoring it, true enough, but we'll be solving for x by using the zero factor property. So let's get to it. So you should already be familiar with the fact that this is a sum of squares, which is normally not factorable with real numbers. However, since we're using complex numbers, imaginary numbers, we'll be able to rewrite this as 4x squared minus 9 times negative 1. Because that's equivalent. You would agree that negative 9 times negative 1 is positive 9, right? Okay, well, being as though we know that I squared is equivalent to negative 1, I can now say that this is 4x squared minus 9i squared equals to 0. And now we clearly have a difference of squares that we can factor and then use the zero factor property in order to solve for our quadratic equation here. So opening up two sets of parentheses, that's what we'll be doing. I'll be taking the square root of 4x squared, which is 2x, and then taking the square root of 9i squared, which is 3i. And from here, thank you, I'll be using a positive and then a negative. See, the positive goes first because I'm an optimist. Thank you. Not to be confused with an Autobot. Thank you. I don't know why you were confused the two, but this is the positive sign before the negative sign because I'm an optimist. I am a positive person. You see? And for you negative people, you can feel free to put the negative sign first. It's just that you're sad and depressed for some reason. So, positive people, put the positive first. There you go. And then we'll be setting each factor equal to 0 separately. So we'll have 2x plus 3i equals 0, as well as 2x minus 3i equals 0. And then we'll be solving for both of these equations that you see before you on your screen. I'll be subtracting 3i to both sides. Oh, yes, I will. Thank you. I'm bringing down 2x, which equals a negative 3i, and then I'll be dividing both sides by 2. So that x equals to negative 3 halves I. That is the first solution to this equation. For the second, we'll be adding 3i to both sides. Yeah, that's right. I'll be bringing down the 2x, which equals 3i. I will then divide both sides by 2. Division principle of equality. Thank you. Appreciate that. And we have our solutions for problem number 2. There you go. Solving a quadratic equation, which is in the form of a sum of squares. Yeah, so as a solution set, I'm going to say that I have x equals to, now pray for the brace, better. It's just a little better. It's just a little better. I'm going to work on this daily until I can draw a brace. I'll be working on drawing braces daily until I can draw one with confidence, because that is one of my Achilles heels. Yeah. Okay. There you go. It's in the red box. That's problem number 2. That's right. Let's go ahead and eat that up. Go ahead. Dinner is served. Problem number 3. We have 3n squared minus 10in plus 8 equals 0. Right. Well, they're clearly showing us that the middle term has an imaginary number in there, so we probably want to show our I squared in this last term. So I'm just going to go ahead and rewrite this as 3n squared minus 10in minus 8i squared. Remembering that I squared is equivalent to negative 1. Negative 1 times negative 8 is positive 8. That's how we were able to write that. You know? So now, using the techniques that I showed you in our Factor Quadratic Trinomials Part 2 video, link right here. Link is, more so, right there is the link. Thank you. I'll be multiplying the first and last coefficient, the 3 times 8, to get 24. Okay, and I'll be looking for factors of 24 that are going to subtract to give me 10. Well, we know we have 1 times 24, we have 2 times 12, we have 3 times 8, we have 4 times 6, and what we need to subtract to give us 10 is the 2 and the 12. So I'll be opening up 2 sets of parentheses here. Oh, yes, I will. And I know that my first term was going to be the variable n, and then I'll be using 12i and 2i. Thank you. And of course, because the middle term is negative, the 12 needs to be negative, and because I'm subtracting to get 10, I need to have the 2 being a positive value. And because I have a leading term of 3, I'll be dividing both of these values by 3. Thank you very much. Your next step is to simplify, if you were wondering. Go ahead and simplify this. You'll have n minus 4i. And any remaining denominators will go in front of the variable. So you'll have 3n plus 2i. And this is how I factor a quadratic trinomial in the form of ax squared plus bx plus c, where a does not equal to 1. And if you want to be down with my method, once again, just check out that video I referred to. The aforementioned video called the Factoring Quadratic Trinomials Part 2 that I clearly mentioned a few minutes ago that you still haven't checked out for some strange reason. So go ahead and check that out because I'm trying to help. It's at this point that we'll be setting both factors. Set them equal to 0. Thank you. Separately, and then solve for both equations. If you have a problem with this equal sign, you're not alone, because I also have a problem with that equal sign. It's better now. Okay, so we can all calm our nerves. Calm the nerves as far as that was concerned. I'm adding 4i to both sides of the equal sign. I end up with n equals 4i. Go ahead and put a red box around that because that's one of your solutions. For the next one, I'll be subtracting 2i to both sides first. Isolating the term with a variable. I'll be bringing down 3n equals to negative 2i and then dividing both sides by 3 so that n equals negative 2/3 I for the second solution. So we're going to be putting a red box around our answers here. As a solution set, we have n is equivalent to, that's supposed to be a brace, negative 2/3 I and 4i. There we go. There we go. Red box it. Red. Boxing it. Just like that. That's problem number 3. That's problem number 3. We have negative 2/3 I and 4i. Move along. Move along. There's nothing else to see here. That's right. Killing the AP classes. That's what we're doing. Using the zero factor property with complex numbers. How cool are we? Cool enough to be solving these problems with complex numbers. The first thing you want to do in problem number 4, which is 2x squared minus 3ix times the square root of 2 equals 2. Is to go ahead and subtract 2 to both sides of the equal sign. Let's do that. Okay. We'll end up with 2x squared minus 3ix times the square root of 2 minus 2, which equals 0. We'll go ahead and ignore the initial 2 here. That's what we're going to do. That'll take care of the square root. See, what you need to do is check out our video on factoring with radicals, and it'll give you some clues as to how to do this. Because I'm looking at this negative 2, and I know that there are 2 factors of 2 that will add to give me 3. Now, I say add to give me 3 because this is what I'm looking at. I'm looking at 2x squared minus 3ix times the square root of 2 plus 2i squared. See, that's what I'm looking at. And I know that I can factor this like so. So what I'm going to do is I'm going to say that I have x times the square root of 2 as our first term. See, that'll take care of that 2x squared by rewriting it as x times the square root of 2 times x times the square root of 2. Then I know that 2 factors of 2 that add to give me 3 are 2 and 1. So I'll be using 2i and I. Just like that. And because the middle term sign is negative, I know that the 2i needs to be negative as well as the I. And this is going to be the factorization of this quadratic trinomial. Yeah, it'll work. See, just go ahead and multiply it out. Have fun with that. And you'll end up with the original trinomial. There you go. So I'm going to set each factor here. I'm going to set each factor equal to 0 and solve for it. That's exactly what I'll be doing right now in this step. So we have x times the square root of 2 minus 2i equals 0. We also have x times the square root of 2 minus I equals 0. And right now what I'm doing is combining all the techniques and strategies that I gave you in the factoring with radicals video as well as the factoring with complex numbers video. All right, to help us factor this equation. From here, we can go ahead and set each factor equal to 0 and then solve for it. So I'm starting out by adding 2i to both sides of the equal sign. This gives me x times the square root of 2 equals to 2i, and then I'll be dividing both sides by the square root of 2, like so. Then we'll need to rationalize this, right, by the square root of 2. Let's go ahead and do that. So you'll end up with 2i times the square root of 2 divided by 2. These 2's cancel out, so you'll end up with I times the square root of 2. As one of your solutions. Just like that. Then the second equation, you'll be adding I to both sides. All right, so the i's cancel out. We'll be bringing down x times the square root of 2, which equals 2i, and then dividing both sides by the square root of 2, like so. And now we'll need to rationalize this once again because we won't be leaving the radical in the denominator. So you'll have the square root of 2 over 2i as your second solution, which means that our solution set here for this equation is going to be the square root of 2 over 2i, comma, I times the square root of 2. Just like that. And there is our answer for this problem. Red boxing it. There we go. Done and done. Problem number 5, we have 6x squared plus 5 equals 0. The first thing I'm going to do is I'm going to rewrite this as 6x squared minus 5i squared equals 0. So notice that we had this quadratic equation with a plus sign here. I know I want to use a zero factor property in order to solve it. So what I'll be using here is the difference of squares factoring pattern in order to factor this. Now notice we are clearly aware that 6 and 5 are not perfect squares. However, we can use radicals to assist us in this process. So I'm going to end up factoring this like so. I'm going to write this as x times the square root of 6 plus I times the square root of 5 times x times the square root of 6 minus I times the square root of 5. Write it just like that, because this will multiply to give me back the original. We know that x times square root of 6 times x times square root of 6 is going to be 6x squared. And when you multiply I times square root of 5 times negative I times square root of 5, you'll end up with a positive 5. You'll end up with positive 5. Yeah. So you can always, once again, foil this back together, distribute, get your arrows popping to multiply that back together to confirm that your factorization is correct. You can always do that. So we have our first factor, which is x times the square root of 6 plus I times the square root of 5. Set that equal to 0. Set the second factor, which is x times the square root of 6 minus I times the square root of 5. Set that equal to 0 as well. And then solve for x. That's what you want to do. So I'm going to be subtracting I times the square root of 5 to both sides of the equal sign here. Yes, I will. I'll be breaking down the x times the square root of 6, which equals to negative I times the square root of 5. I'll be then dividing both sides by the square root of 6. Thank you very much. Oh, yeah. I end up with x equals to, after we rationalize by the square root of 6 over the square root of 6, you'll end up with the square root of 30 over 6i. And that's negative, by the way. It'll be a negative square root of 30 divided by 6i is the solution. The first solution. Yeah, it's the first solution. For the second solution, we'll be adding I, square root of 5 to both sides of the equal sign here. Like so. We have x times the square root of 6, which equals to I times the square root of 5, dividing both sides by the square root of 6, and then rationalizing this. You'll have x equals to the square root of 30 over 6i. And there's your answer. So writing your answers as a solution set, we'll have x equals to negative square root of 30 over 6i, comma, the square root of 30 over 6i. And there you have it. Red boxing it. And that's problem number 5, ladies and gentlemen. Done and done. All right, for problem number 6, we have 30x squared plus 19ix squared root of 3 minus 6 equals 0. That looks fun, right? Well, let's see what happens here. We can rewrite this as 30x squared plus 19ix squared root of 3 plus 6i squared equals 0. Now, I'm not going to be concerned about the 3 within this number because we have that square root of 3 right there. I could have pulled this 3 that I need to be worried about out of the first term, but I'm just choosing not to. All right, so I'm going to put it right here. So that when we multiply the 30 times 2, we end up with 60. So we're actually looking for two factors of 60 that add to give us 19. Let us keep that in mind. And just for your reference here, factors of 60 are 1 times 60, 2 times 30, 3 times 20, we have 4 times 15, we have 5 times 12, we have 6 times 10. So all of these are our factors of 60 here. So what we need is this 4 and 15. So that's going to add to give us that 19. So here we are going to open up two sets of parentheses like so. I'll have my variable x. I'll have 15i times the square root of 3, and I'll also have 4i times the square root of 3. Because my middle term sign is positive, I'm going to need both of these factors to be positive so that they'll combine to give me that positive 19i x square root of 3 that I need. From here, we'll be dividing both of these values by that leading coefficient of 30 and simplifying this. So when we simplify it, we'll have x plus I times the square root of 3 over 2. And when we simplify the second value, we'll end up with 2i square root of 3 over 15. And this still equals to 0. So this is what we have going on thus far, ladies and gentlemen. Any remaining denominators will go in front of the variable. So let's keep that in mind. You'll now have 2x plus I times the square root of 3 times 15x plus 2i times the square root of 3, and this equals to 0. It is at this point that we now have everything factored that you can use the zero factor property. All right, so using the zero factor property, we will set up two different equations. The first will be 2x plus I times the square root of 3 equal to 0. The second one will be 15x plus 2i square root of 3 equals to 0, and then we'll solve for x in each equation. So for the first one, I'm subtracting I times the square root of 3 to both sides of the equal sign here. Next, I'll be bringing down 2x, which equals to negative I times the square root of 3, and then dividing both sides by 2. This gives us x equals to negative square root of 3 halves I as a solution. Okay, then for the second equation, I'll be subtracting 2i times the square root of 3 to both sides of the equal sign, like so. I'm bringing down 15x, which equals negative 2i times the square root of 3. Then you'll be dividing both sides by 15 from here. So divide both sides by 15 like so, and you'll have x equals negative 2 times the square root of 3 15ths I as another solution to this problem. So we can write our answer as a solution set as x equals brace, that's supposed to be a brace, negative square root of 3 halves I, comma, negative 2 square root of 3 15ths I. And there is the solution to problem number 6. Done and done. All right. For problem 7, we have 42x squared minus 27ix times the square root of 3 plus 20 equals 0. Exactly. So let's go ahead and do the following. We'll start out by saying that we have 42x squared minus 27ix times the square root of 3 minus 20i squared equals 0. We have a square root of 3 in this problem. So the 3 can only be pulled from that first coefficient. So we'll say that this is going to be 14 times 3. So this is going to be the 3 that we're concerned with here. So we have factors of 2 and 7 from that 14. We have factors of 2 times 2 times 5 from the 20. And we're looking for factors from this product that will subtract to give us 27. So let's try multiplying 2 times 2 times 2. That'll give us 8, right? And 35 minus 8 is 27. Yeah, 35 minus 8 is 27. So we'll be using 35 and 8. So that technique, guys, is coming from my factoring quadratic trinomials part 3 video, where if the values are getting too big to deal with, just use the prime factorizations of those. So let me show you how all of this will come together in this problem. All right, so what we'll be doing is we'll be using the 35 and 8, as I said, as the factors of our master product, but we also have to keep in mind that that 3 is coming from the first term. So I'll be writing this as x times the square root of 3, like so, and then I'll be using 35i and 8i to take care of the imaginary number. I know that I need to subtract to get a negative 27, so that means that the 35 needs to be negative and the 8 needs to be positive. And because we have a leading coefficient of 14, don't worry about the 3, it's being taken care of with the radical here. We'll divide both the 35 and the 8 by 14. Okay, from here we'll be simplifying this. So this is going to be x times the square root of 3, reducing the 35 14ths by 7. That gives us 5 halves I. Reducing the 8 14ths by 2, This gives us 4/7 I. And then any remaining denominators will be brought in front of the variable x. So that means that we now have 2x times the square root of 3 minus 5i times 7x times the square root of 3 plus 4i, and that equals 0. So from here, you'll use the zero factor property. So we'll be setting each factor equal to 0 and solving for it. So the first one is 2x times the square root of 3 minus 5i equals 0. We also have 7x times the square root of 3 plus 4i equals 0. We'll be adding 5i to both sides of the equal sign. And then we'll have 2x times the square root of 3, which equals to 5i. Then divide both sides by 2 times the square root of 3 to both sides of the equal sign. You'll need to rationalize that right side because of that square root of 3. So you'll end up with 5 times the square root of 3 over 6i. Okay, so multiplying straight across the denominator, we know we have 2 times square root of 3 times square root of 3, which is 3. That 3 times 2 gives you 6. We multiply straight across with the 5 times the square root of 3 to get 5 times the square root of 3, and then you had, of course, your imaginary value I. So that takes care of one solution. For the second equation, you'll be subtracting 4i to both sides of the equal sign, and then bringing down that 7x times the square root of 3, which equals to negative 4i. Go ahead and divide both sides by 7 times the square root of 3. And then rationalize this with the square root of 3 divided by the square root of 3. And now that variable x, it equals to negative 4 times the square root of 3 divided by 21i. And that's your second solution. Writing your answer in a solution set, we'll have x equals negative 4 times the square root of 3 over 21i, comma, 5 times the square root of 3 over 6i. And this is our answer. Red boxing it. Just like that. Let's move on. Problem number 8, ladies and gentlemen. We have 27x squared plus 4 equals 0. Well, we're going to be using the difference of squares factoring pattern to help us on this. I'm going to rewrite this as 27x squared minus 4i squared equals 0. Yeah. I can also show that this is 9 times 3x squared minus 4i squared equals 0. I can do that. Yeah, I can do that. All right. So using radicals and all that good stuff within this problem, I can show that I have 3x times the square root of 3 plus 2i times 3x times the square root of 3 minus 2i. So I'm going to factor this difference of squares in that manner. See, I knew that 9 was a perfect square, right? So I was taking the square root of 9, which gave me the 3 in that first term. The square root of x squared is just x, of course. And then the square root of 3, I wrote it as the square root of 3. Yeah. So that's how I was able to find the square root of that first term. Then, of course, the square root of 4i squared is just 2i. And because we're using the difference of squares factoring pattern, of course, I like to lead with the positive and then the negative in that order because I'm an optimist. Thank you. So I'm going to be setting both of these factors equal to 0 and solving for x. The first is 3x times the square root of 3 plus 2i equals 0. The second one is 3x times the square root of 3 minus 2i equals 0. And then solving for x in each, I'm subtracting 2i to both sides. I have 3x times the square root of 3 equals negative 2i. I'll be dividing both sides by 3 times the square root of 3. You'll then need to rationalize this. You know you got to rationalize this, so I don't even know why you're playing, right? So you'll end up with x equals negative 2 times the square root of 3 over 3 times 3, which is 9i. That is the solution, our first solution that we found. The second solution, you'll have to add 2i to both sides of the equal sign like so. You'll be bringing down 3x times the square root of 3, which equals to 2i. From here, you'll be dividing both sides by 3 times the square root of 3. And then, of course, all that cancels out. You bring down your variable x. And once you rationalize this by multiplying by square root of 3 over the square root of 3, you'll end up with 2 times the square root of 3 over 9i. And there you have it. Those are your solutions to the problem. We're going to go ahead and try to put this in some nice braces for you. So we'll have x equals All right, that's a decent brace. This is going to give me negative 2 square root of 3 over 9i, comma, 2 square root of 3 over 9i. All right, there you go. Red, boxing it. Just like that, ladies and gentlemen. That was problem number 8. Moving on. With problem number 9, we have 36x squared minus 2 plus 7ix times the square root of 6 equals 0. So the first thing that's standing out to me is that this is not in descending order of x. So I want to rewrite this. So I'm going to rewrite it as 36x squared plus 7ix times the square root of 6. And I'm going to go ahead and say it's going to be plus 2i squared, which equals 0. Because we have this square root of 6 right here, we'll be able to realize that we're only really dealing with 6 times 2, which gives us 12. So multiplying this 6 and this 2 here, we're dealing with a master product of 12. So factors of 12, guys, are 1 times 12, 2 times 6, 3 times 4. You're needing 2 factors of 12 that will add to give you 7. That's 3 and 4. Yeah. So because we had that square root of 6 right there, and I knew it was a factor of 36, we were able to hone in on what we really need to be paying attention to in this problem. So let's go ahead and open up 2 really big sets of parentheses to give us some room. And this first term is going to be x times the square root of 6. Yeah, we'll have that. And then I'll need 4i. Yeah, I'm going to need 4i. Thanks. So we'll have x times square root of 6, and then we're going to have 3i here, and the middle term is a positive 7i, so that means that both terms need to be positive. Both of those second terms in the parentheses need to be positive, and because we have this 6 as our leading coefficient here, we'll need to divide both of these values by 6 and then simplify. So that's what I'll be doing next. So I'm rewriting this as x times the square root of 6 plus 2i over 3 times x times the square root of 6, reducing that 3 6 gives us 1/2, or we'll just write it as I over 2 for now, equals 0. And then any remaining denominators will go in front of the variable x. So now I have 3x times the square root of 6 plus 2i times 2x times the square root of 6 plus I, and that equals 0. And this is what our factorization looks like. So now let's go ahead and use the zero factor property. So now we'll be setting each factor equal to 0 and solving for it. We have 3x times the square root of 6 plus 2i equals 0. We have 2x times the square root of 6 plus I equals 0. And then solving for x, I'll be subtracting 2i to both sides of the equal sign, this first equation. That gives me 3x times the square root of 6 equals to negative 2i. Then I'm going to divide both sides by 3 times the square root of 6. Just like that. I have my variable x isolated. However, keep in mind that you'll need to rationalize that denominator. So we're looking at negative 2 times the square root of 6 over 18i, and this reduces to negative square root of 6 over 9i. And that's what we have for that first solution. For the second solution, we'll be subtracting I to both sides. This gives us 2x times the square root of 6, which equals a negative I. We'll be dividing both sides by 2 times the square root of 6. We'll be rationalizing that right side there, getting rid of that radical in the denominator, as we should be doing every time. Thank you very much. And now we have the square root of 6 over 12i. Just like that. Can't simplify that any further. So that means that as a solution set, our answers are negative square root of 6 ninths I, comma, the square root of 6 twelfths I. Okay. There you go. There's your solution. Red box it. Red boxing it. Just like that. That was problem number 9, ladies and gentlemen. Finally, we have problem number 10, ladies and gentlemen. We have 84x squared plus ix times the square root of 7 plus 20 equals 0. Yummy. Well, I do know that 12 times 7 is 84, so that's going to take care of that radical 7 right there. So we're looking at the 12 and the 7, and only the 12 needs to be considered. So from here, we can say that we have the 12 times the 7x squared plus ix times the square root of 7 minus 20i squared equals 0. So the only factors that we're dealing with here are 2 times 2 times 3, as well as 2 times 2 times 5. And I'm looking for factors of this overall product here that will subtract to give me 1. Right. So if you were to multiply 2 times 2 times 2 times 2, that's 16, right? And what's left over is 3 times 5. That gives you 15. So 16 and 15 are going to be the factors that we need that will subtract to give us 1. From here, let's open up 2 big old sets of parentheses here so we can factor this out. All right. So that means that I'm going to use x times the square root of 7 as the first term. And then I'll be using 16i and 15i. And I know that the 16 needs to be positive. It's the sign of the middle term's coefficient. And because we're subtracting to get 1, that 15 needs to be negative. Then we'll be dividing both of these values, the 16 and the 15, by that leading coefficient of 12. That's what we'll be dividing by. So we'll have x times the square root of 7 plus 4/3 I, okay, times x times the square root of 7 minus, reducing the 15 and the 12 by 3, you'll have 5i divided by 4. And that equals 0, like so. And then any remaining denominators will go in front of the variable. So we'll have 3x times the square root of 7 plus 4i times 4x times the square root of 7 minus 5i, and this equals 0, just like that. Okay, so now we'll be using the 0 factor property on this problem. So now I'll be taking each one of the factors that we have here and setting them separately equal to 0. I'll have the 3x times the square root of 7 plus 4i equal to 0. I'll also have 4x times the square root of 7 minus 5i equals a 0. And then solving for x, we'll be subtracting 4i to both sides of the equal sign. That gives me 3x times the square root of 7 equals to negative 4i. Then I'll be dividing both sides by 3 times the square root of 7. Just like that. We'll bring down our variable x, which equals to and we'll need to rationalize this, of course. So go ahead and multiply the numerator and the denominator by the square root of 7. So you'll have negative 4 times the square root of 7 over 21i as the first solution. The second equation requires that we add 5i to both sides of the equal sign to isolate the term with the variable. And then we'll be dividing both sides by 4 times the square root of 7. You'll need to rationalize this by the square root of 7 over the square root of 7, right? So you'll have x equals 5 times the square root of 7 divided by 28i. And that's going to be your second solution. So as a solution set, ladies and gentlemen, we have negative 4 times the square root of 7 over 21i, comma, 5 times the square root of 7 over 28i. And this is our answer for problem number 10. Done and done. So, ladies and gentlemen, this has been the 0 factor property part 3 with complex numbers with me, Mr. Witt, and Fort Bend Tutoring. And as always, please rate, comment, and subscribe to Fort Bend Tutoring's YouTube channel. And if you can, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Peace.
We certainly hope you enjoyed today's mathematics presentations. Did you learn anything? Do you need to review your notes? Take a deep breath and congratulate yourself. I am learning mathematicals.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT.